In today's lecture, we are dealing with the Turing machine example. The first example is 0 to the power of n, 1 to the power of n, 2 to the power of n, where n is greater than or equal to 1. First, we will do the parsing. You got my point? We will take a valid string, and based on that one, we will check our logic. First, we will check our logic. After that one, we will construct the Turing machine. You got my point? First we will take some string over there, and most important point over here is we won't take the minimum string. We won't take the minimum string. We will take the string which has other than minimum string. You got my point? Which is other than minimum string. Actually, in finite automata we are constructing the finite automata by taking the minimum string first, and after that one we will add some more transitions. You got my point? And we will check for the different type of input symbol. We will check for each and every state in finite automata. In PDA also, like Turing machine, we won't take the minimum string. You got my point? We will take other than minimum string. That means there must and should be sufficient number of corresponding input symbols will be there, so that the number of transitions will be mentioned correctly. You got my point? That is why we won't take the any minimum string to be processed over here. Very important point. We will take 2 zeros, 2 ones, 2 twos over here. You got my point? For our illustration. Here the logic is first you have to find out the logic. After finding out the logic, then we have to go for the construction of Turing machine. Here the logic is, we will check for the each and every occurrence of corresponding 0, corresponding 1 and corresponding 2, and we will come back actually from starting 0 to first 2. We will move forward. After processing first 2, we will come back. Initially it is right direction towards first 2. After consuming first 2, there should be a left direction for the another 0 that we want to process. You got my point? The corresponding 0, corresponding 1, corresponding 2. Corresponding 0, corresponding 1, corresponding 2, we will process at a time. This there will be a iteration. There will be a iteration of same thing for same number of zeros, number of ones, number of twos in the corresponding given string. You got my point? This will be iterated as many times. You can see that by processing Q0 on 0, we are replacing with A. This is the output symbol that is placed on the tape after consuming 0. Then we will move forward, and that means we will skip number of zeros and we will go for the first one. First one will be replaced with the B. You got my point? After that one we will skip the number of ones that we encounter. We will go for the first 2. This will be replaced with the C. You got my point? Then we will come back. Until we encounter first A. After first A, there may be a 0. You got my point? That 0 will be replaced with A, and we will skip the number of B's after zeros. We will skip the number of B's. After that one, we will process the 1, and the corresponding C's will be skipped, and the corresponding 2 will be replaced with the C. Again we will come back the corresponding A. After that one we will check for the any 0 is there. If zeros are not there, that means number of zeros are consumed. And if everything is correct, number of zeros and number of ones, number of twos are equal, then after A there should be a B. After B there should be a C. After A there should be a B. After B there should be a C. After C there should be a blank symbol X. If blank symbol is encountered, then there will be accepted state. You got my point? Whatever the logic over here, we are applying in the construction of Turing machine. Q naught initially, and we are replacing first 0 with A, and we will moving towards right direction. You got my point? And after Q1, after actually you can say that in Turing machine, by consuming a different input symbol, generally we will change the state. Remember this point. Generally we will change the state. Q0 purpose is to process 0. Q1 purpose is to process 1. Q2 purpose is to process 2. Q3 purpose is to come back to the corresponding again to the 0. You got my point? That is this iteration simply gives us the corresponding logic. You got my point? First 0 replaced with A and R towards right direction. After by reaching Q1, we are expecting a 1 over there. For first one, we will simply, actually you can see that we will skipping number of zeros. Whatever the zeros that we encounter, we will just skipping and moving forward right direction. Q1 purpose is to process the 1. 1 will be replaced with B and right direction. Q2, whatever the number of ones, we will skip over there, and Q2 purpose is to process 2. You got my point? By processing 2, we will reach the Q3. Q3 purpose is to come back again to the left side. You can observe that here it is left side. By processing 2, we are skipping whatever the ones, whatever the zeros, and you can observe that all these are left side and towards starting we are going for. You got my point? On first occurrence of A, what is this A? This is the A that is replaced whenever we are already processed 0. You got my point? That means after immediate A, there should be a 0. By processing 0, corresponding 1, corresponding 2, there should be a after processing 0 occurrence, corresponding 1 occurrence, corresponding 2 occurrence, there may be another 0. For that one, we are moving forward the corresponding Q0. Again, Q0 purpose is to process 0. You got my point? This iteration will be done unless number of zeros are exhausted. You can observe that for second 0 onwards, we will have number of B's. That means first one already replaced with B. That's why there may be B's, and we will just skip over there. Same way for the Q2, there may be some C's. That means already processed 2's may be there. We are just skipping all those C's. You got my point? While reaching Q3, there may be some B's, there may be some C's, and we are skipping all these things, and we are moving towards left direction. You got my point? This will be done unless number of zeros are exhausted. If number of zeros are exhausted, and after immediate A, if at all a valid string, that means number of zeros, number of ones, number of twos are matching, same n value, then after A, there should be a B. After n, there should be a B. You got my point? On coming back, first A, there should be a B, and number of B's will be skipped over there. After skipping number of B's, there should be a C, and after skipping number of C, there should be a blank symbol. If this type of sequence will be continued, then that string is accepted. You got my point? If number of zeros are excess rather than 1 and 2, that means 3 zeros are there, 2 ones are there. You got my point? 3 zeros are there, 2 ones are there. That means this 0 will be replaced with A. After that one, there is no 1 over there. That is why it will be here itself. It will be here itself. I mean BBBR, and there is no 1. There is no 1. That is why we want to move from Q1 to Q2. You got my point? That is the main point over here. It will stuck over there. If number of zeros are equal to the number of ones, if number of twos are greater, you got my point? Number of twos are greater. You got my point? I mean, all these situations will halt in different states rather than Q5. You got my point? You can check different possibilities over there by taking number of zeros excess, ones excess, twos excess in different scenario. You can check this Turing machine that is constructed. You got my point? Here the most important point over here is that in Turing machine, first we have to find out the logic by observing the language. First we have to find out the logic by taking a valid example, valid string. You got my point? And after that one, we have to decide when we have to change the state and when we have to do all those things, and what is the movement of read write head. That is the most important point over there. You got my point? All these things to be keep in mind while constructing the Turing machine. You got my point? Here the logic is very simple. Corresponding 0, corresponding 1, corresponding 2. You got my point? In this way we will process the entire. In general, in Turing machine, there is a situation where iteration, that means iteration will be there. Lot many examples that I am dealing with. In almost all examples, there is a in general there is a iteration. You can see that there is a iteration. Actually, this iteration simply catches the infinity. You got my point? This in iteration, this circle catches the infinity. I mean, whatever the infinite language, it will be catched over there. You got my point? It will be dealt with. You got my point? You have to take care what are the different transitions and all these things by taking a valid string. Very, very important point. We don't take any minimum string over here. You got my point? We will go for another example in the another lecture. You got my point?